Hello, everyone. I'm Chris Hardin. I'm a technical lead at Oasis Digital. I spend my time working on Angular applications for our large enterprise clients, as well as delivering training for our various Angular-related topics. Today, I'm going to talk about using RxJS to write correct Angular applications. And so it's relatively simple and easy to get something spun up quickly with Angular to get something that looks like it's working. But sometimes things look like they're working. They're not necessarily correct behind the scenes. So today I'm going to show you how RxJS makes it easy to write correct Angular applications that behave well once you get into QA and production. First of all, we're going to start off talking just a little bit about some of the RxJS basics. And so I'm not covering everything on this slide. I mean, not covering all the parts of RxJS here. Just two of the really core components. So first of all is the observable. So observable is the core type of RxJS. It's a representation of a stream of events or data over time. And so we often think of this in terms of water flowing through a series of pipes. So we have this data that's coming in over time, and we want to perform operations on that data, react to that data to update our view. Along with the observable itself, we have pipeable operators. These pipeable operators are pure functions, meaning that they take in an output and they always return, they take in an input and they always return the same output for any given input, and they don't depend on anything else. They don't have any outside side effects. So we combine these pure functions to transform the stream of data flowing through the pipe. We can use these operators to do data transformations, as well as to do things like combining multiple observables, combining multiple input streams to get us the result data that we ultimately want. The nice things about these pipeable operators is they are easily composable and very declarative. So if we know just these two pieces of RxJS, how to use observables and pipeable operators, we can solve most of the problems that we encounter in our day-to-day Angular lives. So when you create an Angular project, you automatically get RxJS out of the box because Angular is built on top of RxJS. And internally, it uses observables for lots of things. Some of the Angular APIs that are exposed to you as a developer also use observables or return observables to you. HTTP client is the one people are most familiar with because all HTTP calls return observables. So in that case, you are forced to deal with it at least a little bit. There are other APIs that also return observables in a more optional way, such as the router and the reactive forms API. Now, most people are a little bit scared of RxJS, and they see it as kind of a whole nother layer of things to learn. And when you have a simple feature, you may think that, well, it'd be simpler to just hook it up without using all that RxJS stuff, just avoid all of that. So here we have our first simple example that we're going to look at. So we have just a simple input field, one input field. And as the user types into it, we want to respond by making one simple HTTP GET request to the backend and then showing some results on the screen. So this is about as simple a feature as you can get. And this is the sort of thing that we do all the time in our Angular applications. So let's try doing that without RxJS. So here at the top, we have our template. And so we're using a form field here, an input form field. We don't want to use any Angular APIs or RxJS. We're just going to do this simply. So we're just going to handle a key up event, just a normal DOM event. And so every time the user types in a key, we're just going to call a method on our component and pass in the event value, the value of the input field. Okay, so that's pretty simple. And then down below, we're just going to use an ng-for to show, iterate over an array of results. So when we call the do search method here, we're going to pass in the current value of the input field, trigger an HTTP request, and then set that array value back on our component. Looking down below, here's the do search method. So in here, we're using an Angular service that really just, makes an HTTP call. All HTTP calls return observables. So the result of this search here is an observable. But we're trying not to do too much with observables right now. So we're just going to immediately subscribe and store those results on our component. Okay, so this looks nice and simple, and we didn't have to know too much about RxJS other than subscribing. But let's see how that actually works for us. Okay, so coming down here, sorry, I'm in the wrong spot. Okay, so this is our first implementation here. And so I do have the console open because I've added some logging statements so that we can see how the requests are actually going out. So I'm a typical user and I don't type very well. And so I'm going to type in a couple things. And no, actually, here I want a dog. Okay, so I wanted to react to the user typing and immediately show them results. But users, you have to type. Users aren't really necessarily that great at typing in the words correctly the first time. Also, we were trying to process every single keystroke. We don't really know when the user is done typing in a search term. So if you look over at the console that I have open on the right, I've put a log statement at the start of each request to the back end and at the end of each request to the back end. And you can see that it's gotten a little bit crazy over here. So if we just look at the tail end of this here, you can see I had 3 HTTP requests that all ended kind of at the same time, which means that I had, at any given point, I had at least 3 open requests to the back end as I was typing. So it typically had, 3 to 4 open requests going, all to return results for one page. So ideally, I would really just want to have one request out there, right? I don't want to be hammering my server with all this stuff. Also, I have no guarantee how long each request is going to take on the back end, or how long it's going to take for those results to travel over the network. So if I'm issuing all of these concurrent requests, how do I know which results are showing on the screen? And in this case, I'm lucky because my last result actually is dog, and it actually does map to what I'm seeing. So as a developer, if I wasn't kind of looking at the console and seeing what was happening, I would look at this. I typed in dog, I got dogs, great, ship it. I'm going to put this into QA. But eventually, a QA tester, hopefully, or maybe a user in production, eventually they're going to encounter a situation where what they see in this box is not going to match what's down below, because I have no guarantee on what order these results come back in. Okay, so the first thing I must fix is that. That's what they're going to, those are the bugs I'm going to be getting reported on me. So let's try to fix at least that one problem of making sure that the contents of this box always match the results the user sees. So that would be kind of our first level of correctness. Okay, so how could we do that? Well, we still don't have to reach into RxJS quite yet. I could solve that by simply adding another property to my component. So here I can add a last search term field. So every time I start a request, I record the search value. And then at some point in the future, when the results come back, I want to do a check. I'm like, okay, these results for this particular search term, is that the last search term that the user typed in? If it is, I'll keep it. Great. Otherwise, I'll just ignore it. Okay, so here I am solving that problem of the race condition of what results am I actually showing on the screen. And I haven't resorted to RxJS yet. But I do have this extra thing I'm having to track manually here. So let's see how that works out for us. Okay, so we'll clear this out. Okay, so here, it's going to look a little bit the same. But if we look over in the logging here, I've added an additional log statement that says keep, that shows which values I'm actually keeping. So here I've issued a lot of requests, and they are coming in kind of a random order, but you don't see that many statements that actually say keep. So I'm only keeping the values that actually coincide with the last value typed in. So I'm solving that one portion of the problem, but I still have a whole bunch of other problems. For one, I'm still sending requests to the server for each keystroke, which doesn't really make any sense. I want to be smarter about that. I really only want to send a request when I'm reasonably confident the user has typed in a full search term. Also, I don't want to send redundant requests. I don't want to send requests for things that, for like empty strings and things like that. Also, if I look at my network tab here, just to see, you can see all of these requests, and they all have a status of 200, which means they did go to the server, they did finish executing and complete. So we're putting a lot of load on our server for no particular reason. Okay. So just talking a little bit more about what went wrong. So what are we trying to achieve here? What are we calling correctness? So on the left here, I have several measures that to me indicate that the app is working correctly. The first one is kind of the most important, the repeatable and predictable results. And we were able to solve that by adding another tracking variable. But we still haven't addressed any of the other bullet points here, the ones having to do with performance and resiliency. So, we still have requests out there that we don't care about. We're not debouncing them in any way. We're handling each keystroke. We're doing nothing to prevent redundancy, to prevent empty requests. And what if the user is on a mobile phone or for some reason has a flaky network connection? We're not doing anything to help them in that case. We don't have any sort of retry logic or anything like that. There are a lot of considerations that we've simply ignored. But as a developer, it works in the simple case when we type it in on our machine. So what are we doing wrong? Why have we failed to meet all these goals? And the thing is, we've tried to oversimplify the problem, right? We see an input box, we need to make an HTTP request, easy to do. So we grab the readily available low-level APIs and quickly hook that up manually. But the problem is, by doing it manually like that, we're actually making it harder for ourselves to actually solve all of the real problems that are there. We're just ignoring them. So we need to use a higher level abstraction and higher level APIs that make it easier for us not only to just solve the simple case, but also handle all of these issues that we run into every time we do anything asynchronous in our project. Okay. So let's solve this using RxJS. Okay. So first of all, let's see how it behaves when we have RxJS in the mix. Okay. So here's the same solution with RxJS. I'm going to clear all of these things out. I don't actually have any logging in this one. We're just going to look at the network tab. Okay, so I'm going to do the same kind of behavior of typing in, oh, no, I said I wanted a cow. Okay. So now if I look over my network tab, you can see I don't have that many requests. So I'm kind of limiting how often I hit the server, trying to guess when the user is actually done entering a search term. So I typed in a lot of characters, but I only have like 5 or 6 requests here. Also, you can see that several of these requests were canceled. So as soon as the user types in a new search term, I no longer care about the previous result. So I want to free up resources on both the client and the server. So I'm going to go ahead and cancel that request. And the ability to cancel the request is a feature that observables give us. So it's a feature that something like promises didn't have, callbacks don't have. So any of those earlier mechanisms for dealing with asynchronicity failed to give us that concept of being able to cancel something, to tell them when we no longer care about the result. So that is a big feature of observables, especially when we're talking about HTTP requests, which is why Angular uses observables for HTTP. So now we have a much cleaner implementation. As you can see, only 2 requests actually made it all the way to the back end. That's just because I was, a little bit slower on the typing. Okay. So we're guaranteed that they always come back in the correct order, and we're not wasting any resources. And we've handled things like, debouncing and stuff like that. Okay. So let's look at the code for this. Okay, so here is the template. So first of all, in the template, instead of using kind of the native DOM events, we're going to go ahead and use the Angular Reactive Forms API. So in the template, all we need to do is put a form control, pass a form control to the input element. And that's going to give us our input observable. So if we're thinking about pipes, that's a pipe of input. And then we're going to have an output pipe that we're going to put down below. So this form control is our input pipe. Down below, we're going to have the results. Before we were iterating over an array of results. Now results is going to be an observable, but that's really easy to deal with in the template. All we have to do is throw on this async pipe. So the async pipe is something that Angular gives you out of the box, and it handles all of the details of subscribing and unsubscribing to an observable for you. And if you think about it, we're writing web applications. Most of the point of the web application is to show data to the user on a view. And anytime you're putting data on a view, you have the opportunity to use the async pipe. So you should be using the async pipe as much as possible to handle all the details of subscribing and unsubscribing. And that removes one layer of complexity that you have to deal with as the developer. So again, all I had to change in this template was putting on this pipe async and switching to using a form control, a built-in API. So we can see that we're going to have an observable for the input data, and we're going to have an observable for the output data. What we need to see is now all the plumbing required to hook those two things together into one pipeline. Okay, so here we have the constructor from our component. So the first thing we had to do is we had to construct a form control. Again, this is from the reactive forms module. And so that's fairly straightforward. We're just calling a constructor here. And so the form control is going to give us an observable called value changes. So in the constructor for our component here, we say, okay, take the value changes observable. And now we can chain a bunch of operations off of it. So all those little things that we need to think about whenever we're processing user input and going out and getting HTTP results, all of those can be handled with a set of small composable operators. And so here we have several of them, about 6, 7 of them. Okay, this takes up about 8 to 10 lines of code. And there's a little bit more code than we saw in the previous example, but it's doing a whole lot more. And they're listed in a very kind of declarative way that's easy to understand once you learn a little bit about what these operators are doing. And RxJS is a very big library and can be kind of intimidating. But this one example shows you kind of a common set of operators that you will use throughout your Angular application. And so you'll be solving these same kinds of problems everywhere. And you can solve them the same way using RxJS. So instead of having to come up with a new way of solving everything ad hoc when using various different other APIs. Okay, so let's take a quick look at what these things are doing. So the first thing we're going to do is apply a map operator, and that's simply going to do a bit of a data transform. So who knows what the user's typing in? They might put in extra spaces, so we're going to go ahead and trim that down. And so as the data flows through, we're going to be constantly working on it and transforming it. Some of these other operators here don't actually transform the data, but they act more as gatekeepers. Or if we're trying to do our plumbing metaphor, maybe some sort of valve that prevents flow. Okay, so we don't want data coming through this pipeline too quickly. So we're going to add in a debounce. So the user has to stop typing for 200 milliseconds before we decide they're done enough for us to actually bother the server with that query. The next thing we're going to do is say distinct until changed. So if a value gets through this pipeline to this point, and it's exactly the same as the last value we would send to the server, we don't want to bother the server with a duplicate request. We can go ahead and ignore that because the results are still going to be the same. So that's another gate that we have to pass through. So if the value makes it through all of these, we're going to do a filter operation. Say, you know what? We don't want to send an empty string to the server. That's just silly. We know an empty string isn't going to match any images, so we're not going to bother with that one. And then the last one is a very important operator called switch map. And this does a lot of the really important work for us. So switch map is one of several operators that takes an input observable and returns a different observable. So here we have the problem of we have an observable coming from the form API that has our inputs. And then we need to make an HTTP request, and that request is going to hand us a different observable. So how do we get these two observables together into one seamless pipeline? And so operators like switch map handle that for us. So we put this switch map into the pipeline of the input observable. And so we say, okay, the input is this search value. We go ahead and we make our call to our HTTP call, passing the search value. Again, this is really just an HTTP request, so it's going to return an observable to us that represents the results. And so the switch map function, well, switch map takes a callback. So what it's going to be returning here is the observable that we got from the HTTP request. So at the beginning of our pipeline, we have input values from the form. At the end of our pipeline, we have results from the server. Okay. And again, we can use these same techniques over and over again everywhere where we need to map a user input to some sort of data from the back end. A couple more things that this is handling for us. You see this retry here. So we have an operator that says, you know, hey, if this fails, if this network call fails, go ahead and retry it 3 times. It's a GET request. It's not going to hurt anything. Maybe they just have a flaky network connection. Maybe the second or third try will get through. And then the last one is, hey, before we go ahead and make this request, why don't we go ahead and clear out the old results so, you know, they don't type in dog and still see pictures of cats from their previous request. So these are a lot of considerations that are happening here in this short amount of code. And we can go through and we can clearly see how each thing is transformed or gated as we read through this kind of declarative list. And this is a technique that we can use throughout our Angular application to handle any type of asynchronous behavior. Okay, so just taking a break for a minute to talk a little bit about who we are. We're at Oasis Digital. If you go to oasisdigital.com, you can see more information about us and our training schedule. We do full stack development and consulting for enterprise customers. And we also provide training on several Angular related topics, as well as a few other things. If you go to oasisdigital.com, you can see our upcoming training schedule and register for any of these things. You notice we do have several different types of free events that are all virtual at the moment, as well as you can purchase tickets for various classes that we have. Okay. Now a little bit more about us here. Okay. So we talked about, so in our first case study, we looked at treating form input as an observable and hooking that up to the HTTP observables. But our applications are full of things that can be thought of conceptually as these streams of events and can be handled using the observable API. If you think about it, you know, your application is sitting there and your user is interacting with it over time. Anything the user does with your application, clicking on something, moving the mouse, all of those things can be modeled as streams of events. Also, you know, any events that happen, such as in response to, let's say, a window.set interval, any kind of a scheduled thing that's happening independent of a user in your application. We can use observables to handle those kinds of event streams. Some other examples, WebSockets. You know, a WebSocket is something that allows that can allow the server to push data and events to your application over time. Those can be handled using observables. If we look at our Angular components, those components have inputs and outputs that change over time. So those can be modeled with observables. Unfortunately, for historical reasons, the Angular APIs don't really give them to us as observables, but we will see how to handle that later. Any type of communication you need to do between components across your application, if you want to set up some sort of pub-sub mechanism, that can be easily done using observables to handle those communications as events in the stream. And this concept of event streams also helps us implement things like centralized data stores. If you want to store all of your global data in a centralized location and want the rest of your application to be able to react to changes in that data, using these observable APIs helps you to do that. So there's many usages of event streams in your application, but not all of the APIs that we use from day to day actually hand us observables. So how do we reuse these same techniques across our application when not all of the APIs consistently give us observables? So that's going to take us to our next example. In this case, we don't have a form input. We have a list on the left that has a list of employees on the left. And if we click on one of those employees, we're going to do a GET request to the backend to retrieve the full details of that employee, and then display that in a detail view on the right. Okay. Assuming that, if this was a real example, the detail request would probably get a whole bunch more information about that particular employee. Okay, so let's see. Actually, so how do we implement this? So again, we don't have a form field. We just have a click event. So how do we handle something like click events? So here is, first the simple implementation without RxJS. And now there's a lot of code here, so we've broken it out into Angular components. So on the left, we have a table view component, and on the right, we have a detail view component. The detail view component expects to get an employee to show employee details. And the list view component, it takes a list of employees. But the thing we're looking at here is the event that it produces. So it has this thing called an employee selected event. And all it's really doing is forwarding a click event that happens internally up to the parent component. So this is really the same as if we're just handling a click event directly. So we don't have a way to get an observable of these click events or these selection events. So right now we're just going to call a method on our component on employee selected. The event here is going to be the employee's ID. And then in our component code, we're going to do the usual, right? We take the employee ID, we pass it to the HTTP client. HTTP client gives us an observable. We don't want to use RxJS at the moment, so we're going to immediately subscribe and stick the result onto our component, and we show it. So again, pretty simple and straightforward, but we didn't really have to deal with RxJS. But let's see what happens when we look at that. Okay. So if we start clicking around in here, sorry, let me fix this filter real quick. Okay, so we start clicking around here, everything seems fine, it's working, and we didn't have to use RxJS. Now, we can't always expect our users to interact with web applications the way we want them to. So a lot of users are going to come in here and they're immediately going to double click this row because they're used to dealing with, let's say, some sort of desktop application. Okay, so double clicking, multiple clicking, rapidly clicking among different things, that is a problem that we encounter all the time, and it can be difficult to solve. And so here, if I keep clicking the same row, I'm making lots of redundant requests to the back end. Okay, so we have a lot of the same problems that we had before. Redundant requests, multiple requests, and also we have the same race conditions and all of that. But double clicking, double submit, those sorts of things, those are old problems that we've been trying to solve for a long time. So let's see how we would fix that with RxJS. Okay, so we're going to need one additional tool from RxJS, and that's called a subject. And so a subject is just an observable that allows us to push data into it. So previously, we've been dealing with observables that have been given to us from somewhere else, from some other API. And we've been handed this observable, and all we know is that this observable somehow pushes data to us, and we consume that data. But in order to take data from a non-observable API and get it into a pipeline so that we can reuse those same techniques that we've already learned, we need some mechanism of pushing data into an observable. So a subject is a special observable that also gives us an API for pushing the data into the observable. And so you can see in this illustration, we're going to put the employee ID into the observable subject, and then the employee data is going to come out on the other end of our pipeline. So how do we achieve this? So in our component code, we simply construct a new subject, and it's going to have number data. Okay, so selected ID is the subject. So we construct the subject here, and then in our constructor, we use the same techniques we've already seen. We treat the selected ID here as an observable, because here we're interested in how we're going to consume the data. Okay, so we use our operators we've already seen. Distinct until change will prevent that double click problem, right? So every time they click, Laura 5 times, we only care about the first one. And then again, we use a switch map to cancel any outdated requests and take the input observable and return the output observable instead. So again, switch map is the magic that hooks our input and our output together into one cohesive pipeline. Looking at the template, what did we have to do? Well, for the output results, again, all we needed to do was throw on this pipe async. Okay, so again, that's going to handle all the details of actually getting the results of this observable pipeline for us. In our view component, the one that actually has the click event, instead of just calling a method in our component, which manually triggers an HTTP request, we're just going to take that data or that event, and we're going to push it into our subject. And so the subject has a method called next. And so we simply call next on our subject and pass in the data. So we're just publishing that data into our observable pipeline. And so it'll flow through these operators, and we will get the selected employee on the other end. Okay. Let's see here. So let's see how that works. We're here. Okay, so here, now if I click on Harold, and trust me that I'm rapidly clicking this guy, and I still only have one request. And as I click back and forth rapidly, yeah, unfortunately, this API is really fast, so you can't see them being canceled. But if this was just something slower, like the Reddit search, you would see that these requests were canceled as I went to the next one. Simply that these are returning very quickly, okay? But you can see from this waterfall view that there are no overlapping requests. Okay, so just take one moment to answer a question that I see in the Q&A. So it said, is the retry being used is something unique to the search bar? So retry, yes, we do recommend using it with HTTP GET requests in general. Basically, you don't want to use it with anything that's modifying data on the server, because you don't want, maybe you do, maybe you don't. But it's safe to use with requests that don't actually modify anything on the server. So if you're just getting some data, it doesn't hurt to retry it a few times generally. And again, the main purpose of that is to account for things like, network connection issues and things like that. So retry is a simple RxJS operator. You put that on a network call, and it simply retries it for you. Again, I wouldn't necessarily do that. I wouldn't do that with, say, a post or a pull request. In that case, well, what if it errored because something actually went wrong on the back end? You don't want to do anything that might make the problem worse or might put your server into a weird state with the data. So generally, we'd want to apply the retry to, requests that don't modify the data on the back end, like a GET request. Okay, so somebody just asked, the difference between switch map, merge map, and concat map. So I don't really want to go into totally difference right now. But one difference is that switch map in particular cancels the previous request. And that's an important feature of the switch map, particularly when you're making GET request. You don't typically care about the old results. So we use a switch map to cancel it. Now, if you're doing some other type of operation, maybe it doesn't make sense for you to cancel the previous thing. But usually when you're making GET request, it does. So there are several operators. All of those are operators that take more than one observable, sorry, that take an input observable and kind of switch it out in the pipeline for an output observable. Okay, so getting back to slides here. Okay, so far we've seen two cases where we had kind of one input stream. Okay, so we have one input stream, we have an output stream, and we need to hook those together. And that's a common thing to do. But let's get a little more complex. What if we have, two inputs that we need to manage? And so we have two kind of observable pipes coming in, and we want to have one coming out. So in this case, in our Reddit example, we've added an additional form field here. So we can choose the subreddit as well as the type in a search string. Okay, so how are we going to do that? So this is adding, we're going to see one more type of operator. What we've been looking at so far are called pipeable operators. We chain those off of one existing observable to transform things going through that pipeline. A creation operator is a different kind of operator. This one you don't stick into a pipeline. You actually use it to combine more than one existing observable to create a new pipeline, a new observable. So here, looking at this example, we have two form fields. So we can use the reactive forms API to get observables for those. So in this case, subreddit is a form control and search is a form control. So we're going to use the value changes property to get the observables for those. Now each form control might have different processing that needs to be done on it. So we can add in some operators before we actually combine them. So let's see, for the subreddit, we actually want to go ahead and start off with an initial value. So here we actually default to this aw value. So on this one, we're going to use an operator called start with to make sure that the initial value kind of primes the pump, starts going through the pipeline. On the search field, we don't actually have an initial value. We're waiting for the user to type something in. So we don't need to bother with the start with operator. But we do need to do some other operations because we need to clean up user type data, right? So we see the same stuff we saw before, the trim, the debounce, the distinct, and the filter. Okay, so we now have two observables that we're working with that have their own pipeline of transformations. But what we want is an observable that represents the results. So we take these two inputs and combine them into one output pipeline. So we simply use the combine latest function here, which takes an array of observables and combines them all together. And so anytime the user changes either of these input fields, the combined values of both fields is going to be sent down this pipeline. Okay, so that's what the combine latest means. It takes, when either of these changes, take the latest values from both of them and pass them further down this pipeline here. So here again, we use the switch format because we want to cancel our old get request. And we're using both the value from the subreddit observable and the value from the search observable. And we're using those to pass to our HTTP GET request, which is now taking two parameters. And again, we use the retry and the start with, just to make it a little bit more robust. Okay, and so we look at how that works here. And we can see that this is working. I don't actually have the, and so as soon as I change either one of these, oh, hold on. There we go. As soon as I change either one of these, I get a new request, and it gets the latest values from each one. Okay. Okay. So kind of to wrap this up a little bit, we'll talk about some things that makes RxJS feel harder than it actually is. So a lot of times people think RxJS is adding too much complexity because they're not quite doing it right, or they're making it a little bit harder than they should. So these are just a few things to be looking out for when writing your RxJS code. So the first one is a subscribe within a subscribe. So we want to maximize our usage of things like these pipeable operators to cleanly connect observables together. If we are subscribing to an observable to take the data out and then walking over to something else and using it again, we're not effectively using RxJS, and we're adding a lot of complexity with managing subscriptions and getting in callbacks and things like that. So if you're subscribing to something just to get the data and then pass it to something else that you're going to have to subscribe to, then we're not quite doing it right. We want to be using something like a switch map or a merge map or something that's going to instead join, either join observables together or take an input observable and switch it out for a different output observable. So anytime you see a subscribe within a subscribe, or just again, some way you just kind of subscribing to, let's say, an observable, taking the data, storing it somewhere else, and then ultimately passing it to something else that creates an observable, really you're doing too much work. We should be looking at how we can effectively combine our observables or hook them up together using the pipeable operators, or in the case of two inputs, using some sort of creation operator. A couple other things, if you're first of all, you should be trying not to manage subscriptions yourself in your components. This is a web application. Ultimately, most things are being displayed to a user on a screen. Anything that's displayed on a screen, you can use the async pipe with. So try not to take on that complexity yourself. Try to defer it to Angular. Let Angular deal with it using the async pipe. Let it manage subscriptions and unsubscriptions for you. And then the other thing is, if you are finding that you have a lot of subscriptions that you're tracking within one component, you probably need to use an async pipe instead. If you really can't, maybe your problem as, maybe an organization problem. Maybe your component is doing too much. You might want to rethink pulling some of that out into a service or splitting it up into multiple components. And also think about, maybe these multiple subscriptions, maybe it's telling you that you have multiple observables that really need to be combined into one pipeline. So these are just a few of the things to be looking out for when looking at your RxJS code. Ideally, you want a clean, simple pipeline of operators that's easy to kind of read and understand, that's hooking up your different observable inputs and outputs. Okay. So we do offer training specifically for RxJS, as well as our regular Angular bootcamp training. So you just go to our website and look for RxJS Angular class. And here we have all of my contact information as well as Oasis. And I will open it up for any questions. So I guess you can either type in a question or actually ask me directly. Okay, so we have a question in the Q&A. It says, in regards to these correctness problems, how often do they really happen with internal apps that are put together on a fast internal network with fast servers? Do we really need all this extra effort? And yes, the answer is yes, they happen all the time. Again, as we're, my experience has been that as developers are sitting there developing on their local machines, they're just doing the minimal amount of testing to say, hey, I typed this in, I got a result I expected. Let me push that up and it'll go to QA. And these are the hardest errors to actually detect and reproduce. So, and I've shown pretty simple examples, but in one of my last big client projects, they brought me into a very large project that had been going on for a while, and started finding like every page had the exact same bug. They had, the system, the back end doesn't have to be all that slow in order for these timing issues to appear. They will appear eventually, especially when you're doing things like putting tables of data on a screen. And so maybe the user's clicking a filter button and then a sort button, and all these things are going back to the back end because you have server-side paging and data and all of this. And so as the user's typing in query filter fields and hitting sort and this and that, all of these things, if done without proper RxJS pipelines, all these things are triggering separate requests and updating the results. And so, yeah, I was having bugs coming in from QA for like literally every page in this application because the application was full of screens with large tables of data that all had lots of different controls. And none of the controls were wired together using RxJS pipelines. So, and again, these problems usually pop up late, making them very painful to then solve. Okay. Okay, so a question about the RxJS training course. The RxJS training course that we provide, it does start out pretty much from the beginning. So you don't have to have any kind of prerequisite amount of knowledge to show up for the class. So it tries to kind of start from the beginning, get everybody on the same page, and then take you through, advanced knowledge and giving you all the tools that you would need. Okay. So next question is, how do you learn to make your RxJS setup so succinct? A practice. And the thing is, a lot of these, we solve the same problem all the time. So, at the end of the day, our applications do a lot of the same stuff over and over again. So all the operators that we solve today, we use those every day because we're always solving those sorts of problems. We're always making HTTP calls and dealing with things like debouncing events and trimming data and filtering things and switch maps. So kind of once you learn to do it once, you've really got the tools to just keep doing it, right? So I don't have to rethink this every time. I'm kind of applying the same technique everywhere I have asynchronous data to deal with. And so just using a few simple examples like this, it really does apply to, kind of everything. We do have some of our Angular Bootcamp curriculum online on GitHub, where we do have several of these really simple examples for you to look at to kind of give you these streamlined, the basic operators that you need. If you go to look at the RxJS documentation, it's kind of overwhelming because there are lots and lots of very specialized operators. But really, I think I've shown you maybe 10 today. And those are really the basics that you need to do probably 90% of your work. Okay. Are there any other questions? Okay. So Zachary is asking about, how do promises fit in to the situation with RxJS? So, I mean, the difference between promises and observables, promises give you exactly one answer and they're not cancelable. Now, sometimes that's fine. If I know I'm just going to make one HTTP request and I want to get that resolved, and I don't care about canceling it. Okay. But like in all the situations we saw today, we were triggering that request multiple times reacting to a user input, right? So if we weren't reacting to user input, let's say we need to load some reference data when a page loads, right? We need that data. We're not doing multiple requests. Yeah, the user could navigate away from the page before we finish, but it's not really going to hurt that much. It's not an expensive query. We're only going to make that call once when the page first loads or that view first loads. So we don't have to be reacting to things. Then it's probably okay to go ahead and convert that to a promise just to make it easier. If we can reasonably say, yeah, we only need to do it once and we don't need to cancel it. And we know an HTTP call always returns either one result or an error. But again, that if we do that too early, if we take things out of the observable pipeline too early by converting it to a promise or something else, well, then we lose the ability to do things like adding in a retry or something like that. So, we want to make sure that we're not sacrificing some features by converting things to promises too early. Okay, so the next question is about testing strategies. Okay, there are a few testing libraries out there for testing RxJS pipelines. I typically don't go to that extent. I typically try to keep my pipelines pretty simple, and just use normal Angular testing tools for that. So I don't have a lot of experience actually using any of the RxJS specific ones. Kind of tend to, my approach to testing is usually, that kind of assuming that Angular works and RxJS works, and trying to keep my observable pipelines simple and streamlined so that they could be tested without using any special tools, just using the asynchronous testing ability of Angular. And we do have a couple steps actually in our Angular curriculum for that. If I could just bring that up real quick. Angular bootcamp. I think that's it. Okay. So if you go to our Angular Bootcamp GitHub, we do have a few steps where we kind of walk through testing with asynchronous code, where we do test a couple observable pipelines. So I would probably start there before getting too involved with some of the RxJS specific testing tools. Where are they at? Yeah, so here, async unit tests. So we do have an example here of how to test asynchronous code using Angular's built-in capabilities. Okay, are there any other questions? One other thing I would like to point out is our YouTube channels. So in addition to our free events, we also record most things that we do and provide those on either our Oasis Digital YouTube channel or a secondary channel that we have called Code Talk Teach, which is more of a kind of a podcast-like radio show that we do here. And then also all of these events that you see published on YouTube, we do also you can attend those live as well by going to our training list here at oasisdigital.com and registering for any of these free events. There will be an Angular clinic immediately after this webinar. So if you have any more Angular questions or problems that you'd like some free help with, you can go ahead and go to oasisdigital.com and click on this link and pop into our Angular clinic session this afternoon.